Hello, welcome to another video here. What we're going to go through today is just kind of an overarching process of that DNA to mRNA to your amino acid and then backwards. So this is going to be that process of protein synthesis, just kind of simplified without all those different moving pieces. So basically what's going on, you can see my chart up here in the upper left-hand corner. There is that other chart that's more of a square that if you prefer that one, you are more than happy to use. You can do so. I'm just using the circle one because it has all full names of the amino acids listed around this outside here. So as you can see, we're going to start up here in this top section with my DNA strand TAC, TTC, GAG, TCT. Now what I'd like you guys to do is just pause the video, work through this one, and then that one if you would like this other one, working backwards. And then you can either fast forward to the end and check your answers, or once you're done, unpause it and listen to me kind of explain it as we go through. Make sure you're having the right thought process here as we go. So starting with our DNA, I'm going to read the actual words of these different nucleotides just because you do need to be familiar with their names to be able to identify them. So we have thymine, adenine, cytosine, thymine, thymine, cytosine, guanine, adenine, guanine, thymine, cytosine, thymine. To get to our mRNA, we're just going to take the complementary of this DNA. So T is going to pair with A is going to go to U, G is going to go to C. And then AAG, followed by CUC, and then finally AGA. Now, what you'll notice is, again, A is going to go to a U in mRNA because we don't have thymine, we have uracil instead. The mRNA is our messenger, so that's what we're going to use as our codon to get our amino acid. However, I do have tRNA in here because if you recall, the tRNA holds the anticodon. That's what's going to transfer the amino acids. The anticodon is how it knows which amino acid to bring in. So all the tRNA is the complementary of the mRNA. So now we're going to do that one, which is just UAC, UUC, GAG, and then UCU. What you'll notice is the tRNA is just the DNA strand. However, it has uracil instead of thymine because you're pretty much taking the opposite of the DNA to get the mRNA and the opposite of the opposite to get the tRNA, which would go back to the DNA. If that makes no sense, don't worry about it. Just go in sequential order than how we just did it. So now to find our amino acid, again, we're going to use our mRNA, not the tRNA. That just tells us which amino acid to bring in. Or which one is coming in. The mRNA is the messenger. That's the one that determines this amino acid here. So starting with AUG, again, we come over to our circle. We find A right here. So now we're stuck in this lower left quadrant. We then go to U. U is right here. So now we're down here. And then we find the G, which is methionine. We can just abbreviate MET. Okay. After that one, we have our AAG. AAG. Leucine, so we'll just go LYS or lysine. Lysine rather. And then CUC, CUC. Here's our leucine. And then AGA, AGA, arginine. We can go ARG. Now you can abbreviate with the first three letters. That's perfectly fine. Most of them, it wouldn't make a difference. If you use the first three letters compared to writing out the whole word, and obviously there are a ton of long words there, so just go with the first three letters. That's perfectly fine. Just sort of matches. So that's our first one. So hopefully that wasn't too bad for you. However, now we're going to work backwards down here. So now we have our amino acids, and we're going to work backwards to our DNA. So where do we start when we're given the amino acid? Hopefully you all said with the amino acid going to the mRNA, because we can't get the tRNA yet. We have to go right to our mRNA here. So this wants to work. There we go. So MET, we just find it on our amino acid wheel here. MET is right here. So it's going to go AUG. Okay. And we find proline. Now, this is different because there are multiple options here. So we could have CCU, CCC, CCA, CCG all give us that same protein. So I guess my question is, does it matter which one we pick? Well, hopefully you said no. because it's still going to give us the same amino acid, which means it's going to give us the same protein. So you could choose any of those combinations that you wanted to, and you would still get the correct answer. It would still be correct. So we're going to go with the easy one. So we'll just go with CCU because that's just right on top there, CCU. We then go to our next one, our lysine. So right here, again, we have that same option. It can be AAA or AAG. So we're just going to go with AAG. And then we have our stop codon. Notice there are the 3 stop codons here, UAA, UAG, and UGA. We'll go with UGA. So that's my mRNA. So now from here, you can either go back to the DNA or just come up to the tRNA. It doesn't make a difference which one you do first or second because you are just using that mRNA for both. So we can start with our tRNA and then go up to our DNA. So A is going to pair with our U is going to pair with our A, and then G with C, GGA, UUC, and then ACU. Up here we can go. A is going to go with, because now we have our thymine back in DNA, so TAC, GGA, TTC, and then ACT. Okay, so there's our next sequence. So that's how we work backwards from it. Now, hopefully these make sense to you. However, if you don't know and you're still confused, please reach out. But throughout this video, we went from DNA to our amino acid, and then we went from our amino acid back to our DNA. This is going to be what you're going to be doing on that kind of worksheet, I guess, that you'll see in this section. Hopefully you guys can work through that. And if you have any questions, please feel free to reach out. Again, if you don't like using this wheel here, you can use that chart, the square chart that's in the PowerPoint, or you can just Google search amino acid chart and you'll get tons of different options. But thank you again for watching, and good luck and take care.